it just suddenly stopped while I was riding it, and I know it wasn't the battery. Well, I knew the battery was charged up because I'd had it all charged up. I only rode up the road a little bit. So that's my job for today. Block of wood like this sort of thing, and just shove it under there. And it's like a stand, and it just helps to keep it stable so you can work on it. So that's quite handy. I'm going to show you inside. It's not that pretty. Here's the battery compartment. So originally these scooters come out with a double lead acid battery. So they've got two little like 12 volt batteries, like motorbike batteries basically, and they're sealed units. But this has been upgraded now to a lithium battery. This is the battery that it runs off, and that's from an e-bike. So it came in an aluminium case, and the aluminium case just wouldn't fit in there. So I took the battery pack out of the case, and now it just sort of fits in there quite snug, but it does fit. But for some reason it's got a problem, and I'm not sure if it's the controller or the battery. I'm suspecting it's the battery, so I think the controller's okay. That's the controller there. It's just a generic. You get them from AliExpress. It's a YK31C, and it's for brushed motors. So it's got two power cables going in. That's what you plug that into, the battery. Those two power cables go in, and then it's got two power cables going out to the motor. Pretty simple. And then over here it's got three cables that go out to the throttle. Red, black and green. They go to the throttle, and then those ones, they go up to the key switch. And besides that, I've got this here is 24 volts coming out, so that 24 volts goes hot when the key's turned on, and that goes out to power all the lights and the horns. This here is my step down converter, and I always get 12 volts coming out of there. That's what powers all the lights and everything. The horns work off 24 volts because these are actually truck horns. They're aftermarket accessory. They run off 24 volts. So just to prove that the controller's okay, because I think it is, even though it did get hot, I think it's still okay because the battery's playing up. I'm just going to test it. I don't think that battery's any good. This one says 10.94, 11 volts, 11.69, so 11 plus 11 is 22.6, 22.7. My meter has a 5 volt minimum. Let's test this one manually. Let's see what it says. Here we go, 4 volts. So if I put them all together, we should have, what did I say, should be 26.7 volts around about. And I've got a little BMS thing that I made up just for this kind of work, so that I can have a spare battery pack. That runs as a 7S. So that means there's 7 cells, lithium cells in series, which means the positive goes out and goes into the negative, and it chains them up in a series, which is exactly what this battery here is. It's a 7S battery. Concentrate just enough so that I don't make a mistake here. That's the input for that one. And then from here I should be able to get a reading telling us that we've got 27 volts, 26.77. And by the way, that meter's not the most accurate. Negative and positive. 27, good enough. Now I should be able to prove using that the motor still works. So I'll turn the key on. I'll plug it in first. Careful, don't want any explosions. Okay. That's the key. Yep. Yep, and I've got lights. So it proves the controller's okay. So that's good news. It's probably the battery pack that's the problem. So, battery pack, scary stuff. I'm not really much of an expert with batteries, so I'm just going to sort of see how far I can get with it, whether I can see anything that I can fix, because as I say, I'm not really an expert. I haven't been trained in batteries. What I've learned, I've picked up through just having this scooter as a hobby, and I have had this apart before. I've taken photos of it. That's why it's got the silver tape, because I had to cut the original heat shrink to get access to the internals. Actually, before we get into this, I'm going to show you what the problem that I'm having is. That there's nothing there, you see. Nothing. Can't get any reading off there at all. It doesn't even have enough juice to light up the LED panel. If I go like this multimeter, because it's battery powered, I can get a reading of volts. See, and it says 27, 28 volts. It says that it's actually fully charged, because when it's fully charged it should be 29.4. And when I plug it into my charger, it just the light goes green on the charger saying that it's full. So it's not taking any charge and it's not giving any current. So there's definitely something wrong here, and I'm suspecting it may be the BMS just because of that kind of behaviour. But we'll see once I get it open and start. Very important you don't do this on a steel bench, because there's a chance that any of these contacts may touch the steel and short circuit, and you'll get big sparks and stuff, because there's a heap of power in this battery pack. This can really go boom. So I'm going to open this. Looks like I've got it down there. So I've got to get past this fish paper so I can actually see the batteries. I'm just going to cut it actually very carefully so that I don't cut into these wires, because if I cut those wires I'm going to short circuit and get a big explosion and sparks, and it'll give me a fright. I don't really want to get a fright. Scary when that happens, and also it can damage stuff. Oh, here we go, look. Easy peasy. See what I mean? You don't want to put your knife in there and short circuit these things, because from here to here there's likely to be a voltage, a potential difference is what they call it. There's a potential difference from here to here in the level of electrons that are charged. Can you see that? Right, so I'm just going to prove that. Is that visible? From here to here, there's a potential difference of 7-8 volts. So So that's 2 cells difference. Yeah, if I was to go across there to there, boom! Big explosion. Now I can see in here it actually looks like it's had some moisture, and because it's rusting, what that shows me is that this is not pure nickel. This is nickel plated probably, but it's definitely got steel. That's why it's rusting, which means that they've used cheap componentry to build this, because pure nickel wouldn't rust. It's one of the tests that you do when you're buying nickel strip, is the rust test. So where am I going to go from here? Because I can see that there's voltage there. What I'm trying to do is trying to diagnose why I can't get voltage out of this pack through these wires. And in order to do that, I need to have access to those wires. I think by memory there's a BMS probably in there, I would think. So I want to get access to the BMS and make sure I can see that it doesn't have any visible damage for a start. And once I can see that, then I can start to diagnose further. I can see there that there's nothing behind the tape that I might be cutting into. It's really important to be careful not to damage anything or short circuit anything with the knife. And cables there. Right, yep, there's the BMS under there. See, they put a piece of foam rubber over the top. Just to protect it from any potential impacts, I suppose. So, there we are. We have access to the BMS. Now, the importance of a BMS, a battery management system, is that when you've got a bunch of cells in rows and you've got the positive and the negative, and you've got the positive goes into the negative of the one next to it, and it goes through, and the positive of that goes into the negative of the next one, and it keeps on going all the way through like a chain, so that when you eventually get to the end and you've got the negative on this end and the positive on this end, what it does is adds up all the voltages of each individual cell. So that, say, to make things simple, we say that a fully charged cell is 4 volts, so that if you've got 7 in a row like that, 7 in series, then you go 7 times 4 to get 28, and that's 28 volts. So when they're fully charged, they're meant to be 4.2. So what that works out to is 7 times 4.2, I think it's 29.4. Get out your calculator. And so what we're expecting to find, the BMS. So the importance of the BMS is that this BMS has both positive and negative that you connect up to it, but then it's also got a cable for each step along the way, so that there's actually 8 cables coming out of this BMS that you have to hook up on the battery system, and each one of those cables goes to the negative pole on each of those individual cells, and in that way this BMS, the electronic circuitry in that chip system, it will calculate the voltage between every step, and it'll make sure that each step along the way the voltages are kept evenly, so that as it's charging all the cells evenly. Otherwise, what can happen without the BMS is if you apply a positive and negative voltage as you're charging, then sometimes one cell might be charging faster than another cell, so it'll get full before that one gets full. And when that one gets full before that one, what's going to happen is that the extra charge that's coming in is going to cause that one to go over voltage, which is and it can actually destroy the battery. It damages the battery when you overcharge it. So the BMS's job is to make sure that they're all kept at an even voltage, so that each step along the way the voltage is equal amongst the whole battery pack, and that way the whole battery stays charged. It charges and discharges evenly. And without that, there's a real risk that one of the cells may be damaged. So what I want to find out is whether maybe this unit here has died, because over time things die, and you can see there's been some moisture in there. So there's a chance that maybe the electronic circuitry has become damp, and it's maybe one of the components in that circuit board has been damaged. You can see there, look, there has been moisture in there. So this battery is very, very highly likely actually that there has been some damage from the moisture, in my mind. That's my expectation. How am I going to test this? I suppose what I can do is I can find the absolute positive and absolute negative on this battery pack and connect them up to this meter and see whether I get some charge. That would be a good start. Because I know that I'm getting a voltage out through here with this, but there's no current. There's no current coming out, not even enough to light up this LED. Like this, see, nothing. So, I've got a spare cable in here. Goodies. Yeah, spare cables. So we'll need the female, see, it's a socket, and the male is a plug. So male and a female. I need the female because always with batteries, with power supplies, you always use female. You never have a male plug sending power. This is one of the golden rules of electronics. Every output of power should be a female plug, a socket, because otherwise with pins, if you've got two exposed pins and there's a potential difference of voltage across them, there's an easier chance for it to touch something and short circuit. Whereas if it's a socket, a plug like this, you can see the way it's been designed is so that it's not easy to short circuit it. You can go like this, and the way it's been designed is it's even got this little ridge in the middle. Can you see that little ridge? And it's designed to help prevent it from accidentally touching something and short circuiting. Not only that, but the actual pins of the socket inset, they're recessed below the surface a little bit, so even if it wasn't for that pin, even if that was dead flat, there'd still be no chance of that actually touching the pin, you see. That's the way they've been designed. So I've got this little spare cable thing that's all soldered up and ready to go. And the problem I have is that it's not long enough to reach each end of the battery, so I need another copper. Okay, so what I found is a bit of cable, two little blocks, there's actually a very strong smell here, and I think what it may be indicating is that one of the cells inside of there may have a leak. So what I might do first of all I'll get this all hooked up anyway. So I just found out all the recording I just did on the diagnosis of this battery pack. It cut out halfway through, and then the storage ran out on my phone, and all of that footage is now gone. So I'm just going to show you what I found out about this, is that I actually got the battery pack open, took it all apart. This is what it looks like. There's all the wires coming from the battery management system, the BMS. And what I found out is that I could only get a voltage from here through my battery powered multimeter. I couldn't read any voltage from this LED because there's no current. There's no current coming through to actually power the LED screen on there. I made this cable up that basically gives me an XT60 plug like that on the end of this cable, and on the other end of this cable I've got two little terminals that I can use just to jam in here to be able to conduct some of this electricity from there to there. And what I'm doing is I'm connecting straight onto the negative pole on this end of the battery pack, straight onto the negative pole, the positive pole on this end of the battery pack, that way bypassing the BMS, because normally with this battery pack the positive would go straight to the battery, and then the negative goes into the BMS, and then the BMS actually provides the negative connection to the battery pack, so that it actually manages every electron that goes out through this plug is meant to travel through that BMS so that it can manage the voltages and balancing of the battery pack. What I'm doing is bypassing the BMS and hooking it straight onto there so that I take the power directly from the battery without using the BMS, and in that way I was able to verify that yes, I do have power coming out through the battery pack. See, you can see it lights up the LCD screen now, and also what I did was I proved that there was enough power through that process to be able to light up my scooter and to drive the motor. You can probably hear the motor. Yep. So it proves that the battery pack is okay, and the problem is the BMS. And what I did was I further inspected the BMS knowing that, and straight away I could see that it was damaged. Straight away when I inspected it, I found that there was some melting on the foam there, and when I looked at the BMS I could see that it's actually destroyed. One of these components has burned completely. That's what the smell is that I could smell, and you can see actually I think it appears to be a diode that's burned out completely. So what it means is that I need to replace the BMS, and the rest of the battery pack should be fine as soon as I replace the BMS. And I think by memory this BMS is a 20 amp BMS, and I know that the motor on my scooter has drawn in the past in excess of 700 watts, so that's more like 30 amps. And I know because I've tested it with this little unit here, putting it in between the battery and the controller. So what that means is I need to find a BMS replacement to replace that component, and I can't use my scooter until I find one. So yeah, that's actually quite good news, because that's a cheap and easy replacement to do. It just simply plugs in. There's one little solder tab there. These are probably about $30–40 on AliExpress, and it may take 6 weeks to arrive, that's all. So yeah, got to do some shopping, but it's good news that it can be fixed. Sweet. See you later.